Good evening students. In this particular segment I am going to explain you that how we can derive the Coulomb's law by the help of the Gauss theorem. Let's suppose if we have not information regarding the Coulomb's law or Coulomb's force and we are just knowing the Gauss theorem. So how we can just derive the Coulomb's law by the help of this particular Gauss theorem. So just see, as we know the basic formula of electric field intensity, that E is equals to F upon Q naught, where Q naught is a test charge, it is a unit test charge. Okay. So from this particular formula, what we can write? F is equals to E into Q naught. E is equals to, F is equals to E into Q naught. You know that what is the meaning of or what is the significance of this particular formula? Let's suppose one is the source charge plus Q, and with respect to this particular charge Q and its field there is a charge Q naught. So what is the force experienced by this particular Q naught charge in its field? That I am going to calculate, that what is the force applied by this source charge on this test charge by the help of this Gauss theorem. So just see here. Let's suppose one source charge plus Q is placed in the free space, okay, and with respect to this particular source charge at a capital R distance there is a point P at which one test charge is placed. Now I have to find the electric field intensity at this particular point P due to this source charge. For calculating a force, I am going to calculate the electric field intensity and then I will multiply with this amount of the charge and then we can get the value of the force. So here I have to use Gauss theorem. So as we know that Gauss theorem is applicable for the closed boundaries only. So that is why we can just take a closed boundary of this particular region of the charge. So I am just going to draw a Gaussian surface. This will enclose this particular charge and its radius will be R, because with respect to this point, at this particular point I have to just find electric field intensity. So I will place this particular point on the boundary of this or inside this particular Gaussian surface. So this is our Gaussian surface, because I have to introduce the Gauss theorem, that is why I am using this Gaussian surface. This is the Gaussian surface. The significance of this Gaussian surface is this, that it is used for the enclosing a charge or to bound the charge or to the bound the field of the charge. Okay, as we know that field lines are radially outward. Okay, so this is the field pattern of this particular source charge plus Q. Okay, at the surface of this sphere, I have considered a small region which area is what? dA. Which area is dA? As we know, the area vector will be always perpendicular outward with respect to the orientation of the surface. So with respect to this orientation of the surface of dA, there is an area vector which is perpendicular outward. And same, the direction of electric field will be also radially outward, means this is the direction of electric field intensity along the direction of area vector. Okay, now we better know that the total electric flux passes through any closed boundary or inside the Gaussian surface is equals to the 1 upon epsilon naught times of the total charge enclosed by this boundary. So from the Gauss theorem we can write phi E is equals to Q upon epsilon naught. This is the total electric flux enclosed by this Gaussian surface. Okay, one more formula is there. That is phi E is equals to Q upon epsilon naught. This is the total electric flux enclosed by this Gaussian surface. Okay, one more formula is there. This is the total electric flux enclosed by this Gaussian surface. which is integrating formula that phi E is equals to closed integration of E dot dA. Phi is equals to closed integration of E dot dA. Okay. Now E dot dA, what we can write? E dA cos theta. As it is clear, due to this source charge, due to this positive source charge, the field pattern will be radially outward, means along the direction of this area vector. So means the angle between D and E will be 0 degree. So here we can write cos 0. Now cos 0 value is 1. So phi E is equals to closed integration of E dA. Now E is a constant, so that will be outside from the integration, and this is what dA. It is a closed integration of this area vector. Let's suppose if I am integrating this whole surface area, so we better know the total surface area of the sphere is what? 4 pi r square, where capital R is the radius. So means we have to just put the total surface area in a place of integration of dA. So now we can just write phi E is equals to E into, and closed integration of dA we can write what? 4 pi into capital R square. It is the value of phi E. Okay, now let's suppose this is our equation number 1 and it is our equation number 2. We can just compare the equation number 1 and 2 and we can get the result. So if I am going to compare these two equations, then you will get Q upon epsilon naught is equals to E into 4 pi capital R square. Okay. So now from here you can get the value of E. So simply you will get E is equals to 1 upon 4 pi epsilon naught into Q upon capital R square. This is the magnitude of electric field intensity due to this particular source charge at r distance at a point P. Okay. Now we need to just find what? We need to find the Coulomb force. As we know, there is a relation between electric field intensity and force, that is E is equals to F upon Q naught. So let's suppose if I need to find the force, then simply what I can use? I can use this particular formula that F is equals to E into Q naught, and from here I can put the value of E. So F is equals to 1 upon 4 pi epsilon naught Q naught upon R square. This is the Coulomb force. And is it clear that two charges which are placed at a capital R distance? So Coulomb force F is directly proportional to Q naught and it is inversely proportional to the square of the separation. So from here also and from directly relation. So this is the proof of Coulomb's law by the help of the Gauss theorem. Okay. And now the direction of force will be along the direction of electric field. So at this particular point, the force experienced by this particular charge which is placed at point P is along the direction of field. So this was our proof of Coulomb's law by the help of the Gauss theorem. I hope that this video is helpful for you. Thank you, stay tuned to our channel, and this particular topic is related to our 12th board. Okay, thank you.